December 25th will bring many reasons to celebrate. It's an annual festival commemorating the birth of Jesus Christ. But in astronomy, that day is also the 2-year anniversary of the launching of NASA's James Webb Space Telescope. Humanity's greatest space-based observatory of all time, James Webb was launched on Christmas Day 2021. It has been our cosmic workhorse, revealing the universe in a whole new light with unprecedented resolution and wavelength coverage to view the cosmos. To celebrate its second birthday, James Webb has just left astronomers feeling festive, as it recently allowed them to image a distant, colorful cluster of galaxies they have dubbed the Christmas Tree Galaxy Cluster. In this cluster, the James Webb Space Telescope discovered flickering Christmas lights in the form of 14 new transient objects, celestial objects that brighten dramatically before fading away. The winter wonderland is officially called MAX 0416 and is located about 4.3 billion light-years from Earth. Hein Yen, an associate professor in the University of Missouri's Department of Physics and Astronomy, said in a statement, "We're calling MAX 0416 the Christmas Tree Galaxy Cluster both because it's so colorful and because of the flickering lights we find within it. Transients are objects in space, like individual stars, that appear to suddenly brighten by orders of magnitude and then fade away. These transient objects appear bright for only a short period of time before disappearing. It's like peering through a shifting magnifying glass." Spotting so many transients in this galaxy was achieved by teaming the James Webb with the Hubble Space Telescope. The sheer number of transients spotted in one go, thanks to the duo, implies there are many more yet to be found within the Christmas Tree Galaxy Cluster. It's almost like a Christmas gift for astronomers that keeps on giving. The light from the Christmas Tree Galaxy Cluster began its journey across the cosmos when the solar system, now 4.6 billion years old, was newly formed and just around 300 million years old. This would ordinarily make it too faint for even the Webb telescope to see in detail. However, a little trick first acknowledged by Albert Einstein made observing this cosmic Christmas a bit easier. In his 1915 theory of general relativity, which concerns the nature of gravity, Einstein said objects of great mass must warp the very fabric of space and time, united as a single entity called spacetime, giving rise to a curvature we experience as gravity. When anything, including light, passes through these curved regions of space, its path gets curved as a result. When an object passes between Earth and a distant light source, the light from that background object takes a varied amount of time to reach us as its path isn't following a straight line due to the curvature created by the intervening object. This can ultimately cause that background object to appear amplified from our vantage point. This concept is called gravitational lensing, as the intervening object acts as a natural cosmic magnifying glass. James Webb has been tapping into this phenomenon with great success to see some of the universe's earliest galaxies, and its view of the Christmas Tree Galaxy Cluster is its latest example. In this picture, we can see many transients in certain regions due to gravitational lensing, which is magnifying galaxies behind this cluster. Right now, we have this rare chance that nature has given us to get a detailed view of individual stars located very far away. While we are currently only able to see the brightest ones, if we observe this long enough and frequently enough, we will be able to determine how many bright stars there are and how massive they are. The transients were found by Yen and the team as they were looking at 4 sets of images captured by James Webb over around 4 months as part of the James Webb Space Telescope's PEARLS program. The team identified 2 objects in the images as supernova explosions that happen as stars reach the end of their lifespans. They are thrilled by this result as they can now use those supernovas to study the galaxies in which they occur. Moreover, the astronomers also found something else extraordinary in the Christmas Tree Galaxy Cluster. A monster star in a galaxy seen as it was when the universe was just 3 billion years old. They have named the star Mathra after the monster MTH Kaiju from Japanese cinema. The galaxy in which Mathra lurks was lensed to around 4,000 times its original brightness. The object lensing this galaxy is currently unknown, but Yen and the team estimate it has a mass between 10,000 and 1 million times that of the Sun. As Jose Diego, research lead author and a scientist at the Institut de Física de Cantabria, said in a separate statement, the most likely explanation is a globular star cluster too faint for the James Webb Space Telescope to see directly. However, we don't know the true nature of this additional lens yet. What's extra interesting about Math's galaxy is that it was also visible and lensed in Hubble Space Telescope images taken 9 years ago. Normally, a lensing object and a background galaxy would move out of alignment over such a period, but Math's home galaxy and the object lensing it seem to have stuck together. In the future, Yen and the team hope to both figure out the nature of this lensing object and uncover some of its characteristics. As Yen concluded, "I will be able to understand the detailed structure of the magnifying glass and how it relates to dark matter distribution. This is a completely new view of the universe that's been opened by James Webb." One of 2 papers detailing the observation of the Christmas tree galaxy cluster was published in November in the journal Astronomy and Astrophysics, while the other has been accepted for publication in the Astrophysical Journal with a preprint available on the research repository AR14. Notably, this James Webb shot isn't the only Christmas-themed image in space this year. Just a few weeks ago, an image of Cassiopeia, the remnant of a star that exploded 340 years ago, was unveiled by First Lady Jill Biden as part of a new White House Advent calendar. These images and others follow a long tradition of astronomers and other stargazers connecting the season of light with cosmic phenomena occurring light years from Earth. But there is genuine scientific wonder involved in some of these festive observations. Unlike the Christmas tree galaxy cluster, Cassiopeia is a lot closer to home. Scientists have long studied the violent stellar explosion and others like it to figure out their role in cosmic evolution. They help galaxies grow. Danny Milovich, an astrophysicist at Purdue University who studies Cassiopeia, wrote in an email, "Supernova remnants also create the elements needed to sustain life, like the oxygen we breathe, the iron in our blood, the calcium in our bones." At 11,000 light-years from Earth, Cassiopeia has been observed by a variety of space telescopes in visible, X-ray, and infrared wavelengths. But Webb's new infrared vision affords a better view. In April, NASA released an image of the supernova remnant using the telescope's mid-infrared instrument. The latest snapshot makes use of Webb's near-infrared camera, which captured gas, dust, and molecules radiating at warmer temperatures. The pink and orange structures enveloped in smoky material against a glittering backdrop of stars resemble an ornament hanging from a tree branch. As Dr. Milovich said, 2 years ago, Webb launched flawlessly on Christmas morning. At the time, I thought it was the best Christmas gift ever. But the telescope is the gift that keeps giving. What's interesting is that James Webb isn't the only observatory sending us Christmas gifts. A distant star-forming nebula that looks like a turkey fleeing a cosmic Christmas dinner has just been captured in a new image by the European Southern Observatory's Very Large Telescope in Chile. The festive photo features the star-hatching clouds of gas and dust that comprise the nebula IC 2944, located around 6,500 light-years from Earth. IC 2944 has a distinctly F-like appearance, so astronomers have nicknamed it the Running Chicken Nebula. In the stunning new 1.5 billion pixel Very Large Telescope image, the wispy gas and dust tendrils of the nebula glow in red, pink, and orange, punctuated by bright blue stars like lights shining on a Christmas tree. The Running Chicken Nebula is about 71 light-years wide and lies toward the constellation of Centaurus. It contains several separate regions, all of which are present in the new image, which covers a patch of the sky as wide as 25 full moons. The brightest region, which appears as the rear of this cosmic fowl, is known as IC 2948. This area is stuffed with bright gas and dust plumage punctuated with bright blue light from hot young stars. These stars, spread throughout the rest of the nebula as well, are carving this cosmic chicken by emitting vast amounts of ultraviolet radiation, which disperses gas and dust, thus helping to curtail further star formation. But some regions of the running chicken, known as Bok globules, are resisting this high-energy radiation and can be seen as dark, dense pockets of gas and dust sprinkled around the nebula. Further up, the celestial chicken is a bright vertical pillar-like structure called IC 2944, which appears almost like a chicken wing in the process of flapping. Atop IC 2944 is the twinkling star Lambda Centauri, which is closer to Earth than the Running Chicken Nebula at just 470 light-years away. The star is so bright that it's visible from Earth with the naked eye. In the upper right of the image, 2 emission nebula regions of superhot ionized gas called GUM-39 and GUM-40 make up the head of the running chicken. A further emission nebula, GUM-41, can be seen to the lower right of the image, forming the foot of the cosmic chicken. Completing the new image is a sprinkling of white and blue stars that resemble falling flakes of snow, each one as unique, individual, and complex as an actual snowflake. Meanwhile, elsewhere in space, to celebrate the festive season, the Hubble telescope has also just gifted us a dazzling starry snow globe that resembles a wonderland of Christmas lights. The image's subject is the billion-star-containing UGC 891, an irregular dwarf galaxy located within the constellation Virgo, some 7 million light-years from Earth. To create the luminous chromatic effect we see, scientists compiled data captured by the Hubble Space Telescope's Wide Field Camera 3 and Advanced Camera for surveys between 2006 and 2021. They ran the data through 12 filters that sampled both broad and narrow wavelengths, covering mid-ultraviolet to visible red light, continuing our exploration of the universe's festive gifts. Another noteworthy celestial event is the observation of a peculiar phenomenon known as the cosmic snowman. This formation was captured by the Atacama Large Millimeter/Submillimeter Array ALMA in Chile and offers a unique perspective on star formation in the universe. The cosmic snowman, located in the constellation of Orion, showcases a dense region of gas and dust where new stars are being born. The array of images reveals a pair of distinct, spherical structures resembling snowmen, separated by a region of diffuse material. This nebula, known as the LBN 762, is a rich area of star formation and provides valuable insight into the processes driving the birth of new stars. ALMA's high-resolution observations highlight the intricate details of the nebula's structure, including the dense cores where star formation is most intense. These observations help astronomers understand how stars gather mass from their surroundings and how their environments influence their development. The cosmic snowman also underscores the diversity of star-forming regions across the galaxy, offering a new window into the early stages of stellar evolution. In addition to these exciting discoveries, recent findings from the Chandra X-ray Observatory have illuminated the complex interactions within galaxy clusters. The Chandra Observatory's latest data has shed light on the high-energy processes occurring in these massive cosmic structures. One particularly intriguing observation involves the dynamics of the Perseus galaxy cluster, which is renowned for its active galactic nucleus and high-temperature plasma. Chandra's X-ray observations reveal intricate patterns of hot gas and the influence of magnetic fields within the cluster. These observations are crucial for understanding the life cycle of galaxy clusters and the role of supermassive black holes in regulating their evolution. The insights gained from Chandra's data not only enhance our understanding of galaxy clusters, but also contribute to broader theories about the formation and growth of large-scale cosmic structures. By studying the interactions between hot gas, magnetic fields, and black holes, scientists can refine models of how these elements influence one another and drive the dynamics of galaxy clusters. Meanwhile, the European Space Agency's ESA Gaia mission continues to make remarkable strides in mapping the Milky Way galaxy. Gaia's latest data release provides an even more detailed 3D map of our galaxy, revealing the positions and motions of billions of stars with unprecedented precision. This comprehensive stellar census is transforming our knowledge of the Milky Way's structure, including the distribution of different types of stars and the dynamics of various galactic components. Gaia's observations have also enabled the identification of previously unknown star clusters and the detailed study of stellar populations across the galaxy. By analyzing these data, astronomers can trace the Milky Way's formation history and uncover the processes that shaped its current structure. Gaia's contributions are vital for understanding our place in the galaxy and the broader context of galactic evolution. In another corner of the cosmos, the Square Kilometer Array, SKA, project, a global effort to build the world's largest radio telescope, is progressing with its development. The SKA will be a transformative tool for studying the universe at radio wavelengths, offering unprecedented sensitivity and resolution. The telescope will consist of thousands of radio antennas spread across vast distances, allowing astronomers to probe the universe's most distant and faint radio sources. The SKA's capabilities will include mapping the distribution of neutral hydrogen, studying the early universe's conditions, and investigating the nature of dark matter. This ambitious project promises to answer fundamental questions about the origins of cosmic structures and the evolution of galaxies. The data generated by SKA will complement observations from other observatories, providing a more complete picture of the universe's complex phenomena. In the realm of exoplanet research, the Transiting Exoplanet Survey Satellite, TESS, continues to uncover new worlds beyond our solar system. TESS's mission is to identify exoplanets that orbit nearby stars by monitoring their transits, or the moments when these planets pass in front of their host stars. This approach has led to the discovery of numerous exoplanets, including potentially habitable ones. TESS's discoveries are expanding our understanding of planetary systems and the conditions that might support life. By analyzing the atmospheres and compositions of these exoplanets, scientists hope to identify planets with environments similar to Earth's, which could be key to understanding the potential for life beyond our solar system. Finally, the ongoing collaboration between various space agencies and research institutions continues to drive advancements in our understanding of the universe. International efforts in space exploration and astrophysics bring together diverse expertise and resources, leading to groundbreaking discoveries and technological innovations. These collaborative endeavors not only enhance our knowledge of cosmic phenomena, but also inspire future generations of scientists and explorers. The continued exploration of the universe, driven by state-of-the-art telescopes, observatories, and missions, ensures that each year brings new and exciting revelations. As we celebrate the festive season with these cosmic highlights, we are reminded of the boundless curiosity and ingenuity that propel humanity's quest to understand the universe and our place within it.